Good morning. Today, let's start with a new chapter, that is chapter number 8, Quadrilaterals. Yes, you all are well aware with this word quadrilaterals. We have already learned this in our previous level, that is in class 8, in detail what are quadrilaterals and the properties of quadrilaterals. Still, let's recall what is quadrilaterals, types of quadrilaterals and properties of quadrilaterals. Now, what is a quadrilateral? A quadrilateral is a simple closed figure with 4 sides, 4 angles and 4 vertices. You can also say that a quadrilateral is a polygon with 4 sides. Now, different types of quadrilaterals. We have learned special types of quadrilaterals, that is parallelogram, rectangle, square, rhombus, trapezium. Even kite is a special type of quadrilateral. Now, angle sum property of quadrilateral. One common property of all quadrilaterals is that the sum of all their angles equals to 360 degree. Means whether the quadrilateral is general or a special, all the quadrilaterals have this common property that when we add all the angles of any given quadrilateral, it is equal to 360 degree. Now, properties of different quadrilaterals. Now, let us just check out the properties of the quadrilaterals which we are all known with. So, the first property, all sides are congruent. We know that parallelogram and rectangle, all sides are not congruent. Congruent means equal in length. Yes, rhombus and square, all sides are equal. Yeah, you can say all sides are congruent. Next property, opposite sides are parallel and congruent. Yes. So, all the 4 quadrilaterals, that is parallelogram, rectangle, rhombus and square, have opposite sides parallel and congruent. Next property, all angles are congruent. Yes, only rectangle and square has all the angles equal. That is, both have all the angles 90 degree. So, only rectangle and square has the property of all angles are congruent. Parallelogram and rhombus does not have this property. Opposite angles are congruent. Again, all the 4 quadrilaterals, that is parallelogram, rhombus, rectangle, square, all the 4 opposite angles are congruent in all the 4 quadrilaterals. Diagonals are congruent. Only in rectangle and square, diagonals are congruent. That is, diagonals are equal in length. Diagonals are perpendicular. In rhombus and square, diagonals are perpendicular, that is, diagonals bisect each other at 90 degree. Next property, diagonals bisect each other. Again, in all the 4 types of quadrilaterals, that is parallelogram, rectangle, rhombus, square, diagonals bisect each other. The last property, adjacent angles are supplementary. Supplementary means when we add the adjacent angles, that is the neighbor angles, the sum should be 180 degree. So, in again, this property is held by all the 4 types of quadrilaterals, that is parallelogram, rectangle, rhombus, square. In all the 4 quadrilaterals, adjacent angles are supplementary. Already we have learned these properties, but again we will learn these properties of with proof. So, properties of parallelogram, that we will learn, but with proof. So, for that, theorem number 1, statement of theorem number 1 is, a diagonal of a parallelogram divides it into 2 congruent triangles. So, the theorem number 1 is, a diagonal of a parallelogram divides it into 2 congruent triangles. Means, and 2 diagonals are there. if we take any one of the diagonal and divide the given parallelogram, we get two triangles which are equal in area. So for that, given ABCD is a parallelogram and AC is one of the diagonal, we have to prove that triangle ABC is congruent to triangle CDA. This because when we are joining the diagonal AC, we get two triangles, that is triangle ABC and triangle CDA, and we have to prove that these both triangles are congruent. So for proof, since ABCD is a parallelogram, we know that in parallelogram definition only states that opposite sides are parallel. So we know that AB is parallel to DC and BC is parallel to AD, as it is a parallelogram. Now using this definition only, let's see what we can find common in both the triangles. That is, now in triangle ABC and triangle CDA, yes, as we have to prove the congruency, let's recall our triangles congruency, that which criteria we can apply here. So for that, first, angle BCA, this angle BCA, yes, is equal to angle DAC, this angle. These both angles are equal. Why? Because BC is parallel to AD. Yes, we know that BC is, these two are parallel, that is, as it is a parallelogram, these two are parallels, and AC is a transversal. So a pair of alternate angles are equal. These are pair of alternate angles when we take AC as a transversal and BC parallel to AD. Next, equality is angle BAC, this angle now, BAC, this angle BAC equal to angle DCA, this angle. Why? Since AB is parallel to CD. Now this already we have seen, AB is parallel to DC and AC is a transversal, so pair of alternate angles are equal. And the third equality is AC equal to AC, because this is the common side between both the triangles. So therefore triangle ABC is congruent to triangle CDA by ASA congruence rule. Similarly, we can prove that triangle ABD is congruent to triangle CDA. Another two triangles also we can prove if we take diagonal BD. If we take diagonal BD, we will get triangle ABD congruent to triangle DCB. These both triangles will be congruent. Hence, diagonals of a parallelogram divides it into two congruent triangles. Theorem number 2. In a parallelogram, opposite sides are equal. This is one of the property of the parallelogram, that opposite sides of a parallelogram are equal. Again, given ABCD is a parallelogram, and we have to prove that opposite sides, that is AB is equal to DC and BC equal to AD. This we have to prove. For that, we have to modify the given statement, that is we will join something or add something. So we do a construction which should be mentioned always after to prove. So we do here the construction, that is we are joining AC. We join the points A and C, that is we are making a diagonal. So construction, join AC. Now proof. We know that diagonals of a parallelogram divides it into two congruent triangles. In previous theorem only we have seen that if a diagonal is there, it will divide the given parallelogram into congruent triangles. Therefore, triangle ABC is congruent to triangle CDA. Yes. Now, if these both triangles are congruent, then AB equal to CD, that is CPCT. Similarly, if we take another diagonal BD, then we will get triangle ABD congruent to triangle CDB, and we will get BC equal to AD. That is the CPCT of that congruency. Hence, opposite sides of a parallelogram are equal. Next, theorem number 3. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Means if it is given that in a quadrilateral, each pair, both the pair of opposite sides are equal, then compulsory that given quadrilateral is a parallelogram. Given ABCD is a quadrilateral in which opposite sides are equal, that is AB is equal to DC and BC is equal to AD. This is given. We have to prove that ABCD is a parallelogram. Parallelogram definition is each pair of opposite sides are parallel. If a quadrilateral, each pair of opposite sides are parallel, then it is a parallelogram. So, we have to prove AB is parallel to DC and BC is parallel to AD. Again we do here construction, so we write construction join AC. Now for proof, in triangle ABC and in triangle CDA, again these two triangles ABC and CDA, AC is equal to AC. This is common. Already it is given AB equal to DC. This is given. Also it is given BC equal to AD. So according to SSS criterion, that is SSS congruence rule, we get triangle ABC congruent to triangle CDA, that is by SSS congruence rule. Now, if these both triangles are congruent, then as CPCT we will get angle BAC, this is our angle BAC, equal to angle ACD. These both angles will be equal. Similarly, we will get angle BCA, this is angle BCA, equal to angle CAD, this angle CAD. These both angles will be also equal by CPCT. But these are pairs of alternate angles. Yes. When we see, you know that AC transversal and DC and AB opposite sides are there. So when we take two lines and AC as a transversal, then we will get AB parallel to DC and BC parallel to AD. Hence, ABCD is a parallelogram. Next, theorem 4. In a parallelogram, opposite angles are equal. Yes. Now, another property of parallelogram, that opposite angles are equal. Let's prove it. Given ABCD is a parallelogram, so as it is a parallelogram, we know that in parallelogram opposite sides are parallel, that is AB is parallel to DC and BC is parallel to AD. Yes. Now we have to prove that opposite angles, that is angle A is equal to angle C. Similarly, angle B is equal to angle D. This we have to prove. For proof, since AB is parallel to DC and AD is a transversal. Now we know that these two are parallel and we take AD as a transversal. So for this reason, angle A plus angle D equal to 180 degree. That is, they are co-interior angles, or you can say consecutive interior angles, or you can say interior angles on the same side of the transversal. So as AB is parallel to DC and we take AD as a transversal, we get angle A plus angle D equal to 180 degree. Let it be number 1. Again, similarly we get AD parallel to BC. Now we are taking AD parallel to BC and we select CD as the transversal. Yes. So we will get angle C plus angle D equal to 180 degree. Again, these are interior angles on the same side of the transversal, or you can write co-interior angles, or you can write consecutive interior angles. So let it be number 2. Now from equation 1 and 2, we get our first equation is angle A plus angle D equal to 180 degree. And our second equation is angle C plus angle D equal to 180 degree. So let's compare both the equations. So we get angle A plus angle D equal to angle D plus angle C. Now when we write this, you know angle D both are common here. So we will cut and we will get angle A equal to angle C. Similarly, we can prove that angle B equal to angle D. Hence, opposite angles of a parallelogram are equal. Dear students, please copy all this with neat and clean handwriting and all the figures in your regular CW. We will continue further in our next lecture. Thank you.